Hi, and welcome to this demonstration of the OakGate storage validation framework. Let's get things going by firing up the controller application. Okay, so what we see here is the typical user interface layout that we're going to be seeing throughout this demo. Down the left hand side here are a number of icons which start up additional functionality, which we'll look at as the demo progresses. When we first come into the application, you can see that there are three tabs up already: Discovered Systems, Configure Systems, and I/O Exerciser. In the Discovered Systems tab, here we see a list of the test appliances that have been discovered that are on my local area network. And we just have the one, which is the MyCE test appliance, and you can see it's actually on the network at the address of 192.168.0.14, and it's currently stopped. So let's start it. So we're starting up the application, and now it's started. If we come over here to the Active Systems panel, we can now expand the entry for the MyCE test unit, and you can see that we have knowledge of 8 ports which can be used for testing drives. Now, if these are actually SAS and SAS and SATA ports, if we had an PCIe drive attached, we would see that in this area as well. So there are actually 8 ports here, although we've only got 4 physical ports in our 4-bay plug-in module. That's because 2 ports are connected to each physical port. So, for instance, port 0300 and 0304 are wired into the same physical ports that we can do dual port I/O operations if we wish to. So, but before we start our test drive, I'm just going to come over here and start up the peripheral control functionality, because I want to associate a power controller which we're going to use to monitor the power consumption of our test drive during the demo. So you come into the peripheral controllers functionality, and we ask to connect to a peripheral controller. When we do this, it asks us which system we want to connect the controller to, the MyCE system. And then it asks us the controller type. You can see here there's quite a long list of controller types, many of which are third-party devices. I actually want to start the mezzanine controller, which is the controller which is integrated with the 4-bay plug-in module. I'm going to connect by TCP/IP, and I know that the address of the system I wish to connect to is 192.168.0.14. So I connect, and it connects successfully to the mezzanine controller. So now I can come across and start my test drive. I happen to know it's in port 0301. And I come across to the Configure System tab, and here are the parameters that I can set when starting the drive. Most of them can be left the default values seen here. The topology is either SATA or SAS. I know it's an SATA drive, so I'm going to leave it as SATA. I now want to associate this drive with a specific port of our power controller. So I add a peripheral module and click port 1 of the mezzanine controller, and now I can initialize the drive. So it's now been initialized and discovered nicely. So I can come over to the Active Systems panel, and I can expand the entries for our drive. And for example, if I come down to the LUN level, I can see on the panel here I'm now seeing some information about the drive. Its product ID is Toshiba. THNSN81Q60SE. Another great product name from Toshiba there. And its product revision or firmware level is 8EET6101. If I click the LUN features part of this panel, I can now see a list of the SATA features supported by the drive, including the maximum Q depth here at the bottom of 32, which is no surprise because 32 is the maximum for a SATA drive. Okay, so we've got our drive up and running. If we go over to peripheral control, highlight the port number 1, I can now turn power measurement on by measuring power, and if I auto refresh this screen, you can see the current power supply and power consumption values. Not much going on at the moment because there is no traffic running to the drive, so it's idling away. You can see the power is being consumed on the 5-volt rail, which is typical for a SATA drive. Okay, so now let's start up the automation functionality. And here we can see in this central panel here a listing of the current test script. In fact, it's blank at the moment. Now we can either load an existing test script in here, one we created previously, or we can go ahead and create a new test by adding test sets and then adding actions in sets. Let's load a demo test which I created before. So I load setup file, demo test, open it, and you can see that it's loaded a little fairly straightforward test that I'm going to use this demonstration. Let's just expand the entries in the test script. And just to talk you through here, the first set is being used to precondition the drive prior to running a test which is going to do 4K random writes, but it will apply an IOPS cap to each iteration of the test. I'll look at this in more detail in a minute. In the preconditioning set, you can see there's a SATA secure arrays action which will clean the drive to an factory fresh out of the box state. There's then a disk prefill action which we're going to use to write sequentially to the drive, and if you look at the setup page of this action, the disk prefill percentage down here on the right is set to 200%. So it will write to 200% of the drive's user capacity, which will ensure that every LBA on the drive has been written to at least once. And then the following test action is to perform 4K random writes to the drive. And the duration of this test action is 6 hours, which is quite a long time, but it's a fairly big drive, a 1.6 terabyte drive, and I know from experience that it's 6 hours is about the time it takes to force the drive into a steady state where the performance of 4K random writes isn't really varying over time. Well, not much anyway. So if we look at the next set, you can see that it's got a loop in it which is going to iterate or repeat for every value of an IOPS cap that we've defined. So look at the setup page for this loop, and we can see down here on the right that it's set to iterate on IOP capping. I can choose other things to loop on, such as rounds, which is just to tell the test to run a fixed number of times, or to iterate on the Q depth, where we might want to vary Q depth or IO size and the like. Let's edit the values that we have here, and you can see at the moment it's going to repeat this loop for an IOP cap of 1,000 through 40,000 in increments of 1,000. so it'll run the test 40 times. Let's just clear those values and change them to an initial value of 5,000 IOPS, an end value of 40,000 IOPS, and an increment of 5,000 IOPS. And usefully, SVF will now generate the 8 required entries, so 5,000 through 40,000, increasing in 5,000 steps. In steps of 5,000, I'll just save that. Okay, so this is a pretty straightforward test, and you can see it's very easy to create tests in SVF. You don't need to do any coding. I mean, for instance, let's just add another test set. So we go to the test line, right click on it, and say add test set. And you can see at the bottom it's added another test set. Let's go to its setup page, and we'll change the name of this to increasing IOPS cap 4K random reads, and then I can add a loop, add item test loop to this new set, and it's got a default of iterating on QDEP at the moment. I'll change that to also iterate on an IOPS cap. I'll edit the values it's iterating on, and give it again an initial value of 5,000, an end value of 90,000, and increase in 5,000 in steps of 5,000. So generate the entries and save them. Okay, now I'm going to add a test line inside the loop. So I add test. I could add actions such as secure arrays or disk prefill, etc. I'm going to add a test action. I'm going to go to the setup page again, call this, give it a name, this action of 4K random reads. Excuse my typing. And then I'm going to define the traffic that I wish to be carried out, the I/O traffic that I wish to be carried out in this test action, which is going to repeat itself for each of the IOPS caps that we've defined. So I go to the LUN path line and then go into the I/O traffic tab, and here you can see the parameters that we can vary to control the traffic. If you've used iometer, many of these parameters will be things you've seen before, familiar to you. So for instance, we have queue depth here. I'd like to set this to 32, the maximum queue depth. We've got an I/O cap being enforced by the loop. Traffic patterns, well, I want it to be 100% random. I'm reading here, and the read size is going to be 4K, so I'll put that in here. I want 100% reads. I don't need to worry about I/O alignment because we're reading, or data pattern because we're reading. By the way, the data pattern in all of the previous I/O traffic settings is all fully random. Okay, so that's all right. So now we're ready, we're almost ready to start this test. Before we do, we've got to associate this LUN path 0 with the test drive that we want to be used in this test. Now we can actually run this test against multiple drives at the same time by adding more LUN paths and associating each of those LUN paths with a different drive. We're only going to be testing one drive in this demo. So we can go across to the I/O exerciser, and the I/O exerciser has an entry in it at the bottom here, which we can copy by right-clicking it, copying all LUN settings. Then we can come back to the Test Automation tab, cut across to LUN Association, select LUN path 0 and paste the LUN path details that we've just taken across from the I/O exerciser, and associate LUN path 0 with our Toshiba THNSN81Q60 CSE drive. So now we're ready to start our test. I hope you can see it was pretty easy to add that third set there. So here we go, press the start button. It's telling us here that, or asking us if we'd like to remove the previous test results associated with this script. I do want to remove it, so I click remove. I could, if I wished, have gone across and moved those results somewhere else or rename them prior to starting the test. So as our preconditioning step started, it turned blue. The secure erase is now finished, so it's turned green, and it tells us it was successful in that it passed. And now we're on to the disk prefill step. Now this is going to run for an hour or so, and then the pre-con, the 4K random writes step is going to run for 6 hours. So before we pause the demo for a number of hours, let's have a quick look at some of the things we can look at whilst things are running. So first of all, let's come across to the I/O exerciser and click its I/O traffic panel. And you can see here the nature of the actual traffic that's running right now. You can see it's running at a queue depth of 32. It's 100% sequential. If we come down a bit further, we can see that the write size is 128K. We're doing 100% writes. The writes have been aligned to 4K boundaries, which is good. And the data pattern that we're currently writing is 100% entropy, which is 100% random. Okay, so now we can come across to the left-hand side of the screen and press the dashboard icon. And up comes this display, which shows some nice graphs of the current IOPS and bandwidth performance and the cumulative IOs since we last started, which were accumulated since we last started the dashboard, and the cumulative bandwidth. Okay. Let's now go back to the peripheral control panel, and we can see the current power consumption. And we can see here that in terms of power consumption, that all the action is on the 5-volt rail. There's nothing really happening on the 12-volt rail or the 3-volt rail. Okay, so as I said, we're going to need to wait several hours for this test to complete. So I'll pause the demo at this stage and come back later to see how things are going.